Hello, I am Akshat Yadav, joined by my Parth Gupta and Sridhar Tiwari. Today, we are presenting a research on meta service design and implementation for content delivery network cloud environments. Our presentation will cover the design, implementation, and evaluation on meta services that optimize CDN operations in cloud environments.
Thank you, Akshat. In the next 10 minutes, we will walk you through our comprehensive study covering introduction to the problem, related work in the field, our proposed system architecture, database design, meta service implementation, experiments we conducted, a brief study case, and our conclusions.
Content delivery networks, or CDNs, have revolutionized data delivery by enabling scalable, efficient, and low latency services. However, managing CDN backends in cloud environments presents significant challenges, including resource allocation, load balancing, and security concerns. The core of our solution lies in the concept of meta services, middleware solutions that handle critical backend tasks such as scheduling, monitoring, authentication, and storage management. Our research demonstrates how these meta services can significantly enhance CDN efficiency in cloud environments.
Looking at existing research, cloud computing provides flexible pay-as-you-go services, while CDNs enhance content delivery through strategically placed edge servers and sophisticated load balancing algorithms. Meta services aren't entirely new. They were originally developed for grid computing but have been adapted to manage resources in cloud-based CDNs. What sets our work apart in this paper is that the previous research has typically focused on isolated aspect of resource management, whereas in this study, it integrates meta services for comprehensive CDN optimization. Cloud migration involves moving IT resources from traditional on-premise servers to cloud-based platforms, enabling businesses to access computing resources more flexibly. This transition is key to understanding the context of our research.
Now I'm going to tell you a system architecture. Our proposed system architecture consists of five primarily components working in unison. First, the client component that interfaces with the system via browsers. Second, the web servers that handle HTTP requests and communicates with the middleware. Third, the management meta services layer that forms the core of our solution, managing scheduling, authentication, monitoring, and storage. Fourth, the cloud server pool consisting of content servers that deliver data to clients. And finally, the folks that collect data on server resource utilization. Key feature includes dynamic load balancing, resource optimization, and real-time monitoring through props.
Database design. So, our database design efficiently manages both static and dynamic information. We implemented two types of tables. One is static tables that includes the user info table storing user credentials like username, password, and the resource info table recording server capabilities such as CPU speed, memory, and disk size. Dynamic tables consist of load info table tracking server workload and resource usage, and the utilization table updating real-time data on CPU, memory, and I/O utilization. Probes update these tables periodically, providing meta services with accurate information for authentication, scheduling, and monitoring decisions.
In our implementation, we integrated four key meta services. The authentication meta service verifies user credentials via the JAS framework and logs all user activity, including login and logout events. The monitoring and storing meta services work together with monitoring update resources, information, and tracking changes in real time, while storing manages resources usage data crucial for scheduling decisions. The scheduling meta services allocates resources based on dynamic load data and a recommendation index formula that it is developed in the paper. This formula integrates bandwidth, CPU, memory, and input-output utilization to intelligently prioritize service.
For experimental validation, we set up a 5-node test network with heterogeneous bandwidth connections, where node 1 served as the client node. Bandwidth between nodes varied from 300 kbps to 1000 kbps to simulate real-world conditions. Our testing procedure followed a comprehensive workflow. Users access the system via login page, authentication validates credentials, users submit queries for resource files, or meta services process these queries. The scheduling components calculates recommendations and finally rank candidate server as presented to the user, who can then select their preferred server to access content. The experimental results confirm that our system successfully ranked candidate servers based on multiple factors, including resource utilization, network bandwidth, and current workload.
So, to conclude our research successfully designed and implemented meta services for CDN applications in cloud environments. The four essential meta services, authentication, monitoring, scheduling, and storing, proved effective for managing backend systems in CDN cloud environments. Our prototype system enabled users to submit queries for data files with meta services collaboratively determining optimal resource choices based on various performance factors. Experimental results demonstrate that the system could successfully rank candidate servers based on multiple criteria, enhancing user experience through intelligent resource allocation. Future work includes further performance testing and improvement to the prototype's integrity. The research contributes to the growing field of CDN optimization and cloud resource management.
Work builds upon significant prior research in the field of content delivery networks, cloud computing, and meta-services architectures. Key influences include work by Molina et al. On CDN implementation, Broberg and Biosa research on meta-CDN, and Du et al.'s design of OGSA-based meta-service architecture. The comprehensive integration of these concepts into this meta-service framework represents an important step forward for CDN management in cloud environments. This approach addresses gaps in the existing solution by providing a unified middleware layer that handles the authentication, monitoring, storage, and scheduling in cohesive systems. Thank you. With this, we'll end our presentation.
Thank you.